Hey everyone, welcome back to the channel. If you are new to my channel or to the series, I am just solving all 150 NeetCode problems, having never seen them before. So last time I looked at the sliding window category, and I'm doing all the easy problems first across the entire NeetCode 150. Then I'll go back and do all the mediums, then all the hards. But I did this best time to buy and sell stocks and solved that one. So we're through 7 of the 150 problems. And today we're moving on to the linked list category. And excellent. Looks like there's 3 easy problems here, which is actually great. Because linked lists is something I have not touched in about 5 or 6 years. So I'm a little bit intimidated by this section, but hopefully it comes back to me and I relearn it here. So we're going to hop into this first one, reverse linked list. So let's make sure, yeah, this is Python, and given the head of a singly linked list, reverse the list and return the reversed list. Oh, nice, they have a diagram here. So we want to go from, we want to simply reverse the lists given a pointer to the head of the first list. So given a pointer to this 1, we want to return presumably a pointer to this 5 that extends to the rest of the list. And return the reversed list. What does this mean? So I'm given head equals this. Is this giving me a list? Or is this giving me a pointer? Okay. So this was confusing me initially because these look like lists. But here it looks like both are type list node. Oh, okay. And so they've defined a class for us, list node. Excellent. Yeah, perfect. So I don't have to worry about returning lists or anything. I'm just going to pretend that these are pointers and there's a self.val and a self.next. So that's perfect. And just a second example here, if we're given a pointer to 1, we just need to flip those. And if we're given something empty, we return nothing. So a number of nodes in the list will be up to 5,000, and the value can be between negative 5,000 and positive 5,000. Okay, right. So I'm going to hop down to the whiteboard here, because I have to be honest, I don't remember the algorithm for reversing a linked list, so I'm going to have to solve it here and then implement it. So this should be fun. Let's see how we get on. I'm going to start, the one thing I remember is I need to just start out with the simplest case. And that is the case here of just reversing 1 pair in the list. So let's start with that, keeping in mind we have access to the value of a node as well as the next. So we don't have a previous pointer because it's a singly linked list. So I guess that's important as well. Okay, so let's think about the simplest possible case. And the problem said that we're going to get the head. So we will be given head, which points to 1, which points to 2. So that's what we're basically given in the simplest case. And so I need to return basically that. So how do I do this? Well, one thing that we could do is in this case, we could simply switch the values, right? We could say basically temp equals head.val. Then we could say head.val equals, sorry, I'm running out of room a bit. We could say that head.val equals head.next.val. And then we could say head.next.val equals temp. Does that make sense? So if we start with the example on the left here, so we would store temp as head.val, which is 1. Then we would change head.val to whatever head.next.val is, which is 2. And then we would change head.next.val to whatever temp is, which is 1. And that equals this, so we're done. So in the case where it's just 2, that would work. Now, the problem is, as soon as, that only works for the case of 2, I think. Because as soon as we have this case, where it's 3, we can't really do that, because we need 3 to end up as the first node, and we don't have access to that. So that example I just did works well for swapping 2, but I don't think this is going to work well as a solution to the whole problem. I think I need something a little bit better than that. So let's keep this in mind, and let's move on to a better solution. And again, let me pull up an example that's not, actually, let me just do another example of just this one. Is there a different way that I can do this so that it works? I don't think I have any runtime constraints here. So one thing that I can do is send, this is something I'm remembering from when I studied this in school, I think. Let me make this list bigger. What I might be able to do, because remember, I need to swap these two, and then the 3 I actually don't have to swap at all, because what I want to end up with is 5, 4, 3, 2, 1. If there was another number here, then I would want to switch both of these, both of these, both of these, right? So the idea that gives me is I could send a pointer down the linked list each time that I need to make a swap. So basically, I could call something like temp, which is a node. It originally points to head. I send it all the way down. So I take temp and I send it all the way down to the end. And then once it gets there, I swap the 1 and the 5. Then I move my temp node back one to the 4, and I move my head node forward one, and then I swap the next set. So this might be something that works. Or I could just keep the head and I could have temp and temp start. And just move those nodes up and down the list so that I can do my bidding with them. The question will be, since I don't have a previous reference, so how to move this backwards is going to be a bit of an issue. So what I might have to do is just calculate the length of the list at the beginning by sending a node all the way down, so I know the length of the list. And then I can loop. The first time I send temp all the way to the end. The next time I send temp to one less than that. The next time I send temp to one less than that, until I get to the middle of the list. That's going to be super slow, but I think with a singly linked list, it might be my best bet. So let's go ahead and try that. Sorry for the long explanation on the whiteboard there, but I am definitely relearning this as I go, and so I needed to stop and really think about that one. But let's see if I can write that all up in the code. So like I said, I think the first thing I want to do is get the length of the list so I know how many swaps I'm going to need to make. So the way we can do that is we can say, how can we do that? So it looks like I have an init function to make a node. So I will say temp, or actually I'll call it counter. We'll say counter equals, I should be able to do this, list node, and I don't have to give it anything. It'll set the value as 0 and next is none. Or maybe I can say, yeah, val doesn't matter, but next I want to be equal to head, so that this node is pointing to the head of the list. And then while counter dot next does not equal none, and then I'll call this counter node. Oops, counter node, and then I'll have an actual list length, set that equal to 0. So while counter node dot next does not equal none, we will say actually we'll set this equal to, we'll say list length equals list length plus 1, and then we will say counter node equals counter node dot next. So basically we're moving it along. And let me just make sure this works on the edge cases at the beginning. So if we point it to the head and head is empty, like head is none, I guess I need that case at the beginning. If head equals none, we can just return none. So we'll just return head. Make some more space. And then if the list length is 1, because that's another edge case, what will happen is head's not none. So we point to head, the list length is 0. Counter node next does not equal none. But in this case, it does equal none. So actually, I think I can solve this with or head.next equals none. We just return head. So in the case where it's only one node, reversing that wouldn't do anything. So you would just want to return the pointer to the original node, which is head. So I think that handles the edge cases. So then if this is length 2, we start out with list length is 0, while counter.node.next does not equal none. It doesn't. We increment 1. I think I have to set this to 1 to start. Yeah. So then it's not none because it would be a 2. We increment the length to 2. We switch to 2. But then the next one is none. So we stop and we know the length is 2. Okay, great. So that should keep track of our length properly. Now, once we know the length, we need to start doing the switching. So, and we know we need to switch the length of the list divided by 2 times, basically. Or there might be, actually, there's probably an even simpler way. Let me make a start node. We'll set that equal to head. An end node. We'll also set that equal to head. And then we need to send the end node to the end. So how many times do I need to do this? So while start node does not equal end node. Actually, no. I think I like the other way better. So I will just, we know exactly how many times we need to switch. So so num switches right equals list length divided by 2. And that makes sense because if the list length is 2 divided by 1, we need to make 1 switch. If the list length is 5, 5 divided by 2 is 2.5, but we drop the decimal, so we just need to make 2 switches, which is correct, right? We switch 1 and 5, 2 and 4, and that's it. If the list length was 6, we would make 6 divided by 2, which is 3 switches. These two, and then whatever 2 were in the middle. So we know our number of switches. So for I in num switches, I think I actually need to say range, because I can't just say for I in a number. I think I need to say it like that. If I have that wrong, I'll come back to it. So for I in range num switches, what we want to do is send we need to make 2 nodes, so start node equals head, end node equals head as well. We need to send the start node we just want to keep where it is. So I suppose I need a moves equals 0. So start node is head, end node is head. And then what we want to do is send the end node all the way to the end of the list. And we can do that with a while loop. So while, we know we want to move it. So if the length of the list is 5, we want to move it 1, 2, 3, 4. So 1 less than that. Maybe I can say moves to make. Equals. List length. -1. And then for x in moves to make, again, I think I need to say range moves to make. We need to say end node equals end node dot next. So now we move it into position at the end. And then once we're finally there, we need to swap them. But also I need to move the head node into position, which I think I can just do each time. Okay, so I do that. Then what I do is make the switch. So temp equals start node dot val, start node dot val equals end node dot val, and then end node dot val equals temp. That's just a common way to switch two values using a temporary value. And then I just need to clean up. So start node equals start node dot next. End node will get moved up here. So I can actually swap this out, because we'll just move the same one, but the end node needs to start at the head each time and then move all the way to moves to make. And moves to make has to equal moves to make -1. At the end of all of this, I should be able to just return the original head, because I haven't changed that. Okay. That was quite a bit of code. Let's give this a run and see what happens. Yeah, okay. End node equals end node. That was my fault. Let's try again. No attribute val. I thought I did have an attribute val. Can I not do? Okay, hold on a sec. Let's print out the type of start node. And let's print out the type of head. These are both list nodes. Okay, sorry, if it's type list node, I should have access to the value. Self.val equals val. If I print head.val, that gives me 1. But if I print start node, dot val. Oh wait, that also gives me. Oh, none type object has no attribute val. So I'm getting a case where I'm switching something with a type of none. Oh, okay, I see. So this is a very common error in linked lists. I recall. So at some point, start node is equal to head. So in the case where head is none, or head.next equals none. Okay, so it's neither of those cases. So it's, we update these. We set start node equal to head. We know the number of switches we need to make. The first switch switches head with whatever the one at the end is. We set start node as start node dot next, which should be head dot next. Make one last move. Return head. Let's try running this for just the empty one. That works fine. Sorry. Let's try running it for just the 2 case. So that already fails. So the question is why? So we have our counter node. Let's print list length. Make sure that returns 2. Oh, 3. Oh, shoot. So it is 0. So I was trying to make one extra switch and that was taking me off the edge. Okay, but I still got the wrong answer. So I'm spitting out 2, 2 when I should be spitting out 1, 2. So in this case, head is that. I get the list length correct. The number of switches would be 2 divided by 2, which is 1. Moves to make is list length minus 1. Which means list length minus 1, which is 1. So num switches should be 1, moves to make should be 1, start node is head. So for I in range, num switches, which is only 1, end node is head. We move end node to the next node. Temp is start node.val is end node.val. Oh my goodness, that should be an equals sign, not a minus. Oh, good grief. Sorry, everybody. If you saw that before me, I really apologize. And let's do 1, 2, 3, 4, 5. That's super frustrating. Sorry about that. So that worked for everything. Let's go ahead and submit it. My only worry is this is too slow. Okay, amazing. Yeah, my runtime is terrible. Like really terrible. And the memory usage was fine. So yeah, everyone, clearly that solution was terrible, but it worked. So I'm glad that I got it. That being said, I might need to add a second video just showing how I could have done this much, much better, because obviously I solved the problem, but this solution was far more complicated than it needed to be. So stay tuned. I might make another video where I go back and do this in a much simpler way. But until then, I did finish it. I will check it off. But yeah, stay tuned. I might come back and have another think about this. Thanks so much for watching.